Hello friends, in this video we're going to be solving the Diophantine equation 97m plus 43m equals 1. Now, a Diophantine equation is one of the problems of number theory, and when you look at this equation, it looks like a simultaneous linear equation, but in this case we have two variables, m and n, and then we have one equation. In an ideal sense, for a simultaneous linear equation, we need to have two variables and two independent equations so we can get the solution to the equations. But in this case, we have two variables, m and n, but only one equation. So we're going to use a well-known technique known as the Euclidean algorithm to solve this equation. So let's get on it. So looking at this, we have 97m plus 43m equals 1. So this is the Euclidean algorithm we are about to start. Now, the first step is we divide 97 by 43. So this is how we're going to write this. We're going to have 97 equals 43. You write it this way. Now, 97 divided by 43, that will 97, 43 will go into 97 twice. And when this happens, we're going to have a remainder of 11. Let me give an example. Now, when we have 45 divided by 30, okay? Now, when we do this division, the quotient is going to be 1 multiplied by the divisor plus the remainder, which is 15. That's exactly what happened here. 45 divided by 30 is 1. The divisor is 30 and the remainder is 15. So that's what we have here. 97 divided by 43 is twice. That's why we have this number in parentheses. And then we have a remainder of 11. So this is the Euclidean algorithm. Then we move further. We're going to perform this algorithm until we get this number at the right hand side, which is the greatest common divisor. Now, I'm going to perform the Euclidean algorithm on the numbers 43 and 11. So this is going to be 43 equals 11. Now, 11 is going to go into 43 about 3 times. And of course, 11 times 3 gives us 32. And then the remainder is going to be 10. So this is where we are. Now, we're still going to perform the Euclidean algorithm on the number 11 and 10. So this becomes 11 equals 10. 10 will go into 11 once, or 11 divided by 10 is once, and the remainder is 1. So once we get the remainder, which corresponds to the greatest common divisor, we stop our Euclidean algorithm. Now, the next step to the solution of this equation is to solve for the remainders. Now, in solving for the remainders, is just applying basic principles and procedure in mathematics, making the remainder the subject. Now, if you look at this equation, when I make 1 the subject here, we're going to have 11 minus 10 multiplied by this, because I'm going to have 10 leaving this section. So this is what we have here. So we're going to have, now I'm going to solve for the remainder from the beginning. So So we're going to have 11 equals 97. Now, when I multiply 97 by 1, it is still 1. Because at the end of the day, the numbers in parentheses will form our solution. Plus 43. Now the negative sign, 43 was supposed to assume a negative sign if it meets 97. But the negative sign is going to be placed with the number in parentheses. So it is going to be minus 2. Of course, this is like having minus 43 times 2. So the same procedure will occur in this second equation and in the third equation. So here we're going to have 10 equals 43 multiplied by 1, which still gives us 43, plus 11 minus 3, because this figure is supposed to get a negative sign. Then finally we solve for the remainder here. 1 is a remainder here, so this is going to be 1 equals 11 multiplied by 1 plus 10 open bracket minus 1. So when we are done solving for the remainder, the next step is to backward substitute. Backward substitute. So this is what I mean. Now looking at the last equation we have here, the last equation we have is 1 equals 11 multiplied by 1 plus 10 multiplied by minus 1. So when we take a look at this equation, we will see that here we have 10 and here we have 10. So I'm going to write the last equation. 1 equals 11 multiplied by 1 plus, instead of writing 10, I'm going to write the whole of this value. I'll substitute the whole of this value here. Because in this second part, 10 equals 43 multiplied by 1 plus 11 multiplied by minus 3. So I'm not going to write 10 here. I'm going to substitute for 10. So this is going to be 43 multiplied by 1 plus 11 minus 3. Then we have our minus 1, which is a common 10 that will open up our bracket. So this is going to become 11 1 plus. Now we're going to open up our bracket with this, and because minus 1 is in parentheses, we're going to multiply it by this number. So this is going to be 43. 1 multiplied by minus 1 is minus 1. And then here we have 11. 3 multiplied by minus 3 is going to be 3. Now looking at this equation, we have common terms. 11 1 and 11 3. So this will add up. So we're going to have 11 1 plus 3, that gives us 4, plus 43 open bracket minus 1. So we're almost done with our work. We're soon going to get our answer very soon. So just keep watching. Now, in the first part of this equation, we have 11 equals 97, 1 plus 43 multiplied by minus 2. So we're going to substitute this value for 11 here. Instead of writing 11 here, we're going to write the whole of this value. So I have 1 equals, instead of 11, I'm going to write 97 multiplied by 1 plus 43 multiplied by minus 3. And then we have, remember we have 4 here. 4 opens the bracket up, and then we have plus 43 and then minus 1. Now, when this is done, the number 4 here in parentheses is going to open up our bracket here. So this is going to become 1 equals 97. 1 multiplied by 4 is 4. And then we have 43 minus 2 times 4 is minus 8. And then we have plus 43 minus 1. Again, we have a common term, 43. So we are simply going to add up the numbers in parentheses. So this is going to be 1 equals 97, 4 plus 43 minus 1. And this is the solution to our equation. Now looking at this, if you look at what we have originally, we can see that we have arrived at our original Diophantine equation. And here, clearly, you know that this is 97m. Looking at our final solution, the coefficient of m is 4, which means that our m is 4. Now looking at this, the coefficient of n here is 43. The coefficient of m here is 97, and here we have 4 attached to 97, so n is 4, and then n is going to be minus 9. N will be minus 9. And at the end of the day, when you substitute these values m equals 4 and n equals minus 9, when you multiply 97 by n, 97 by 4 plus 43 by minus 9, we are going to obtain 1, which is the greatest common divisor. Thank you for watching this video, and look out for more of our exciting and interesting videos.